Alright, good morning 8th graders. Today we are going to go through Chapter 8, Lesson 5. We're going to talk about using the distributive property, and specifically using the distributive property to factor an expression. So up until now we've been multiplying or adding expressions. Now we're going to work backwards, and it'll work a little bit like dividing. So here's our objectives for today, and we'll get started. So when we talk about factoring polynomial, that involves finding the completely factored form or taking anything out. So here's an example. If I have 1.6w squared plus 6w, I can rewrite that as 1.6w times w, that's w squared, plus 6 times w. The w is the common factor, so I take that out or factor it out. Inside the parentheses then I have what is left, which would be the 1.6w plus 6. So let's take a look at another example here. It says use the distributive property to factor each polynomial. So the first thing I want to look at is what is the greatest common factor between these two terms. If I first look at the numbers, I have 27 and 18. The greatest common factor between those two numbers is going to be 9. Then I look at the variables. They all have to have the variable for it to be common, and we want the lowest exponent that they all have. So this is a y squared and a y, so the lowest exponent that they all have would be y. So then I make my parentheses. Now essentially what I'm going to do is divide both of these monomials by 9y. So 27y squared divided by 9y. We've worked with this already. Okay, 27 divided by 9 is 3. Y squared over y, I just have 1y left. Also, so then the next term, 18y divided by 9y. 18 divided by 9 is 2. Y over y is 1, so it's just 2. This would be my factored expression, 9y times the quantity 3y plus 2. And I know that it is correct because if I were to distribute this back out, I would end up right back where I started. So that's how you can check your answer to make sure it is correct. So now let's try B. I have negative 4a squared b minus 8ab squared plus 2ab. So if we start with our numbers, negative 4, negative 8, and 2, the greatest common factor there is 2. When I look at the a's, I have an a squared, an a, and an a. So the largest exponent that they all have is 1. When I look at the b's, I have b, b squared, and b. The largest that they all have is b. So altogether my greatest common factor is going to be 2ab. From there I go through and divide each one of these terms by 2ab. Negative 4 divided by 2 is negative 2. A squared divided by a is a. B divided by b is just 1. So I don't even need to write it down. In the second term, negative 8 divided by 2 is negative 4. A over a cancels out. B squared over b, that's just b. And lastly, 2ab divided by 2ab, that is 1. So this would be the factored form of this polynomial. And again, if I wanted to check my answer, I could distribute this back in and multiply it back out, and I will end up right back where I started. So at this point, you guys can pause the video and try 1a and 1b on your own. I'll be back in a minute to go through them. So we should be back from trying 1a and 1b. Let's take a look quickly. 1a has a greatest common factor of just 3. Since w and v are different, I can't include either one in my greatest common factor. So I can just factor out a 3. And when I do that, I'm left with 5w minus v. 5w minus v. And if I multiply it back out, I get to where I started, so I know it's correct. 1b, since this last term doesn't have a number, I can't take out any numbers as part of my greatest common factor. So I look at my letters, or my variables, and I can only take out a ut. So what I'm left with is 7ut plus 21t minus 1. And that is my answer. So moving on, another concept that we can do, which moving forward is going to be pretty important for us into the next few sections, is called factor by grouping. Essentially, if we have 4 terms in a polynomial, we can factor the first, or we can group the first 2 terms together and the second 2 terms together and factor each set of those binomials out individually. So here's our example. If I have ax plus bx plus ay plus by, I factor out an x out of the first quantity and a y out of the second quantity, and that leaves me with a common binomial factor. Since both of these are multiplied by the quantity a plus b, I can factor that out, and that leaves me the quantity x plus y times the quantity a plus b. So that was the general form. Let's look how it works specifically. So here's my 4-term polynomial, and I want to group the first 2, and I want to group the last 2. From here, it's just 2 problems like I just got done doing. The greatest common factor out of the first set of parentheses is going to be 4r. So then what's left is q plus 2. Now when I factor the second set of parentheses, I want to factor it in such a way that I'm left with the binomial q plus 2. So here, if I factor out a 3, I'll be left with q plus 2. So altogether I have 4r times the quantity q plus 2 plus 3 times the quantity q plus 2. Since both of those terms have a q plus 2, we call that a common binomial factor, we can factor that out. Put that in front, and what I'm left with is 4r plus 3. So q plus 2, 4r plus 3. Now, the way you can check this is the same way we multiply any 2 binomials together using our FOIL method. First, outside, inside, last, and you see that we get those 4 terms that we started with, so we know we have factored it correctly. Okay, I'm going to do one more, and then I'm going to let you guys try one. So 2a here, I group the first 2 terms and the second 2 terms, and notice how I include that negative sign with the r. That's going to be important when we factor to make sure we get our signs correct. So in this first set of parentheses, the only common factor that they have is n. If I factor that out, I get r plus 5. Here, I want to end up at r plus 5. It looks like they don't have any greatest common factors, but if I just leave it, that's negative r minus 5. That's not what I want. So what I can do is factor out a negative 1. So if I divide both quantities by negative 1, they turn into r plus 5. Now I have that common binomial factor that I'm looking for. So I take that out and put it in front, and I'm left with n minus 1. And again, if I wanted to FOIL, I could get back to the original. So go ahead and pause the video at this point and try 2b on your own. I'll be back in a second to go through that with you. Okay, we should be back from trying 2b. Group these 2 and these 2. Out of the first one, I can take out a 3p, and I'm left with n plus 5. So again, I want to be left with an n plus 5 here. On first glance, I could factor out a 4, but when I do that, I'd be left with negative n minus 5. So I want to factor out a negative 4. That way I get n plus 5. Okay, so n plus 5 is the common binomial factor. N plus 5 times the quantity 3p minus 4. FOIL it, we get back to the original. We have done it correctly. Now, a special case or something a bit strange that can happen when we try to factor by grouping are these next examples. So let's take a look at those. So I group the first 2 and the second 2 just like I have already. I factor out my greatest common factor of 2m, and I'm left with k minus 6. Now, take a look at the next set of parentheses, 42 minus 7k. If I just factor out the GCF, the greatest common factor, of 7, I'll be left with 6 minus k. Is 6 minus k the same as k minus 6? No, it is not. So I can't just factor out a 7. What I want to do is factor out a negative 7. So when I factor out a negative 7, now I'm left with negative 6 plus k, which I can rearrange and write as k minus 6. And I will do that. So now there's my common binomial factor. I'll factor that out, and I'm left with k minus 6 times the quantity 2m minus 7. So keep a lookout for those. They call them additive inverses. Why don't we just do, let's look at 3b. 3b is a little more interesting. Try 3b on your own, and I'll be back in a minute to help you out. So go ahead and pause the video. Okay, we should be back from trying 3b. Let's go through it. Group the first two and the second two. Here I'm going to factor out a p, and I'm left with 3 minus 2p. So on the second one, if I factor out a 9, I would have negative 2p plus 3, and that's what I have. So I'm going to factor out a 9, and I get negative 2p plus 3, which we have to be able to recognize that these are the same quantity. Okay, this 3 minus 2p and negative 2p plus 3, those are the same. You don't have to rewrite it like I'm about to do, but I think especially at the beginning it can be helpful to make sure you know that yes, this is the same, because that's negative and that's positive. So then my 3 minus 2p is the common binomial factor. P plus 9 is then left over. And if I were to FOIL them out, I would end up with those 4 terms, maybe in a different order, but I would get those 4 terms. Okay. Now, the second part of the lesson today is going to be very, very important again moving forward. It is a huge concept in terms of Algebra 1. It is called the zero product property. Here is what all of this means in a nutshell. When you have two things multiplied together to get 0, one or both of those things must equal 0. That's the only way you can get 0 as the answer to a multiplication problem, is if one or both of them are 0. So that's what this says down here for any real numbers a and b. If a, b equals 0, then a equals 0 and b equals 0, or both a and b equals 0. Okay? So it says, recall that the solution or root, which is another name for the solution of an equation, is any value that makes the equation true. So what we're going to find here in these next equations is we will have more than one answer that will make this true. Okay, so solve each equation, check your solutions. So for A, I have two things multiplied together equals 0. We'll call this one A, this one B equals 0. So what that means is that either A equals 0 or B equals 0, or both of them equal 0. So if A is equal to 0, 2D plus 6 equals 0. Solve that equation. Minus 6, 2D equals negative 6, divide by 2, D equals negative 3. Okay, now the other thing, B, if B equals 0, 3D minus 15 equals 0. I add 15, 3D equals 15, divide by 3, D is equal to 5. So now it says check your solution. So think about this. If I plug negative 3 in, okay, that's going to turn this quantity to 0. My answer will be 0. That works. If I plug 5 in, that'll turn this quantity to 0. Anything times 0, it doesn't matter what the other quantity is when D equals 5, it would be 16. Anything times 0, which this binomial would be, is going to equal 0. So since they both work, they're both my answers. I have two answers. So two values satisfy this equation. Okay. So a big thing in order to use the zero product property is your equation has to be equal to 0. So in this equation, it's clearly not equal to 0. We want to make it equal to 0, so I'm going to subtract 3c. So now I have c squared minus 3c equals 0. Do I have two things that multiply together to equal 0? No, these are two things that are subtracted. So I want to factor out a c, and I'm left with c times c minus 3. Now I have two things multiplied together to equal 0, c and c minus 3. So we set each one equal to 0. C equals 0, c minus 3 equals 0. This one's already solved. This one, I add 3 and c is equal to 3. Those are my two answers, or roots, to the equation. Okay, go ahead and pause the video and try 4A, B, and C. 4A, B, and C. I'll be back in a minute to help you out. Okay, we should be back now. 4A is quite simple. That's already factored, so we have two things set equal, or two things multiplied together to equal 0. So that means 3n equals 0 and n plus 2 equals 0. I divide by 3, n is equal to 0. There's one answer. I subtract 2 over here, n equals -2. There's my other answer. 4B is a little bit more challenging because we have to factor it. So I factor out an 8b, and I'm left with b minus 5 equals 0. Two things multiply together to equal 0. So you set both of them equal to 0. 8b equals 0, b minus 5 equals 0. Over here I divide by 8, and b is equal to 0. Here I add 5, and b is equal to 5. And that's really all there is to it. 4C. 4C is a little bit more difficult because now it's not set equal to 0, so I have to set it equal to 0. So I add 10x to both sides. I get x squared plus 10x equals 0. Now we need to factor the left-hand side, and it factors like this. Two things multiply together to equal 0, make both of them equal to 0. And I end up at 0 and -10. So there you go. That's how you can solve some equations using your factoring, and more importantly, the zero product property. The zero product property. If two things are multiplied together to equal 0, one and or both of them have to equal 0. So here's a word problem to finish up on here. Penny is a fox terrier who competes with her trainer in the agility course. Within the course, Penny must leap over a hurdle. Penny's jump can be modeled by the equation h equals -16t squared plus 20t, where h is the height of the leap in inches at t seconds. Find the value of t when h is equal to 0. So essentially we're just taking this equation and we're plugging in 0 for h. Okay, so I'm going to rearrange it just a little bit. I got 16t squared plus 20t is equal to 0. I've plugged in 0 for h. So now it's just like what we got done doing. Let's find our greatest common factor. Okay, our greatest common factor could be 4t. You could possibly do a -4t. It's not going to matter much. So 4t is then -4t plus 5 equals 0. So two things multiply together to equal 0. I have 4t equals 0 and -4t plus 5 equals 0. Divide by 4. T is equal to 0. Minus 5. -4t equals -5. Divide by -4. T is equal to 5 over 4, which is the same as 1 and 1/4, which is the same as 1.25. So now, you might be asking yourself, this is a real life problem, how can it have two answers? And to be completely honest with you, a lot of times one of the answers doesn't make sense or it's not of use to us. But in this case, both of them really, I mean, I guess they're useful or they're valid, you could say. So if this is a graph of Penny's jump, we'll say at the bottom here, this is seconds, and this is height. So just imagine the dog's path as she jumps. She's going to jump up, get as high as she can, and then come back down. So it'll look something like that. Okay, I'm going to zoom in just for a second. It'll look something like this. So imagine what this is. This is where t equals 0, where her height is 0. So the time in which her height is 0. Okay? So the time in which her height is 0 is when she starts at 0 seconds and when she finishes. So the important part of this answer is right here. When she comes back down, 1.25 seconds have elapsed. So that means she was in the air for 1.25 seconds. Okay? So that's how we can have two answers, because we have a curve like that. That is the word problem, and that is the end of the lesson. Here's the assignment. Go ahead and get started, and hopefully you behave yourselves and have a great weekend. If you have any questions, please come in and see me. All right, bye.